presentation overview on the new BC code. And we have with us Zachary May from BC Building and Safety Standards, and also Tim Bryce, Assistant Manager of Inspection for the City of North Vancouver. And one thing I'd like to ask, we have a lot of people here tonight, so if you could hold your questions till the end, because maybe some of them will be answered as they go through it. It's a very long presentation normally. I think they told me it's a full day thing that they normally do. They tried to stream it down for just the HVAC guys. So we'll let them go through, and we'll have a question and answer period at the end, all right? So you guys take it away.
So first of all, there's a microphone back there, and I won't stand over there, but can everybody hear me? In the back, can you hear me okay? If I fade off, or if you fade off, let me know, and we'll go from there. I'm Tim Rice. I'm the Assistant Manager of Permits and Inspections of the City of North Van. Assistant, so that if anything goes wrong, it's not my fault, it's my boss. But if anything's good, then I did it because he's an old guy, you know, the young guy does it. Zach and I do this along with another team of presenters for the building officials who've done it around the province. It's typically about an 8-hour presentation. And at that point, we like to tell them that we're turning the water on them like a fire hose. Now, you guys are HVAC guys, so we're only going to do it an hour because you're way smarter, obviously. You've all had a beer or two and a nice thing to keep you awake, so it'll be easier, and we'll turn the fan on high to get through this. Yeah? You like that? I thought about that in the car on the way over. Come on! You're going to have to work with me on this. Some of this stuff is a little dry. We're here to talk to you about the brand new 936 that's in the building code. We're going to give you a brief background. We're going to talk about something called compliance paths, and then we're going to talk about building envelope, and then we'll get to the good stuff of HVAC. So you'll have me for the first little bit, and then Zach's going to take over after that. So this is what the energy requirements look like in the building code for now. Actually, sorry, up to December 19th. I'm used to giving this presentation before it's already in play. Part 3 buildings are those big complex buildings. I'm sure you're all familiar with them. Either you do ASHRAE 90.1 or the NECB, or if it's less than 5 stories, you would jump over and do just those simple insulation tables that's in Part 10. There was a performance path, that blue path on the right, but nobody really used it. Nice and simple. That's not what we deal with anymore. It looks like that. That's what it was. That's what it is. Lots of different ways to get through the code, and this is what we call compliance paths. 936, Section 936 of the BC Building Code was adopted and enacted on December 19th. It includes a number of different compliance pathways, something called a prescriptive pathway that you can get through the code, where it's you must do what's written in the code. Prescriptive has a little bit of a trade-off option in there. If you can't quite do what they ask for you, you can do a little bit something different. It has something called a performance pathway, which you can do some modeling and bring in some extra help to look at the way you're building and you can do some really interesting things from that point of view. And then there's even a certain type of building that can't use that at all, and it sends you over to a whole other document called the National Energy Code for Buildings. National Energy Code for Buildings is a national model document. It goes on along with the National Building Code, the National Plumbing Code, the National Fire Code. It was introduced in 2011 after a long hiatus since 1997. Well, the last edition was the Model National Energy Code for Buildings. But we won't be talking too much about that kind of stuff, but just so you know, there are different ways to get through what we're talking about today. Today we're going to talk primarily about the prescriptive paths to get through. What is Section 936? It is the biggest midstream amendment to a building code ever, as I believe. Yes, go with it. That has ever been done to a building code. There was 110 pages of new code added into the building code. If you have the paper copy, your binder no longer closes. If you have the online copy, don't worry, it's all there. We already talked about the multiple pathways to compliance. Several different options for different building types. You can really tailor the way you're getting your energy performance to what that building looks like. It's a systems approach, and I'll talk a little bit more in a second, and we talked already about the performance-based option. It treats the building as a system. We're going to talk a lot about tonight about how you, as the HVAC industry, you're no longer going to be a plug-in at the very end. You can't add you guys in and hope that the building works. The building has to be designed from the get-go with understanding how are you going to heat the water? How are you going to heat and cool that building? Where is your electrical going to go? Where are your chases going to go if you're going to be doing plumbing in certain elements? You have to have that performance-based design. It's truly magical when it works. We were talking at this table this morning, there's going to be some serious growing pains as we get there. remove some barriers to new technology, so you can start to see some of those neat elements that you wanted to use before that weren't technically allowed by the code anymore. It brings in some new opportunities to bring in some neat elements. Current code requirements, you guys are all familiar with this. Sorry, this is actually current before. Yeah, so this is up to and including December 18th. It was specific to BC. Zach wrote a bunch of this. Good job. Insulation tables in Part 10. You remember that? It was just what's stuffed into the wall, the pink stuff that goes in between the studs. Had some stuff on water efficiency. And it wasn't a performance measure. It just had an 80-20 rule. Just get there as best as you can. This is the old table that was in the code. You might have seen this before. Depending on the different zones that were of your heating degree days, that's the insulation that you had to include in the walls. And that's what's called a nominal insulation factor, and we'll talk about that in a bit. As you can see for us down here in the Lower Mainland, attics are 40, suspended cathedral ceilings are 28, your standard wall are 20. This is all familiar to you guys. This has all changed. Insulation tables in Part 10 are completely gone. Now it says go check out 936. And it applies to all Part 9 houses and small buildings. So this is single-family homes, duplexes, triplexes, small buildings that are standalone like a doctor's office or a woodworking shop. It's not just homes. It's not just houses. It applies to a wide range of requirements. This is a handy-dandy table that's available online that talks about those different pathways and that flow chart that we talked about at the beginning. Only some of the pathways are available to some of the different types of buildings that are covered in Part 9. So single-family dwellings, that actually has the most options available to them. And single-family dwellings in this case includes duplexes. The prescriptive path is one of the ways to get through it. The performance path, that's where we talked about having a model of your house done through the HOT 2000, or also known as being done by someone called a certified energy advisor. You might have heard that before, or you can do it yourself. That's another option for single-family dwellings, and using that National Energy Code for buildings, that's an option as well. Residential buildings that are larger than a single-family home, or have a larger common space, or small industrial and commercial, they can't use that performance option. They have to use the prescriptive path, or they have to use the National Energy Code for buildings. And then where it gets really interesting is your medium-sized industrial, and any building that has any non-industrial or non-residential component that's greater than 300 square meters, you have to use that National Energy Code. So there are some buildings that will be outside of the building code as we know it, and you will have to go and buy another code and have a look at it. So that's something to think about. Okay, just quickly running through the building envelope section, because it does tie into what we're here to talk about tonight. The focus is on total building performance, as we already said. Heat transfer and air leakage between the conditioned space and the unconditioned space has to be accounted for. And then the last two bullets there, windows must conform to 9.7, and the properties of the insulation and vapor barrier and air barrier have to conform to 9.25. So those last two bullets there are for you to, and more for general contractors to remember that while Section 936 is new and it's exciting and you have to comply with it, the rest of the code is still there to comply with as well. So you'll see as you go through 936, it'll say go check out what's also involved in the other parts of the code. Sometimes those links are there, sometimes those cross links aren't. So it's important to remember that whatever you're installing also has to comply with the rest of Part 9. This is one of the biggest concepts that changed in this new energy regulation. No longer are we talking about the stuff in the walls in between the studs, which we call nominal insulation. Now we're talking about something called effective insulation and an effective R value. So on the left there, nominal insulation only accounts for the insulation layer, where you stuff that in the walls. It only accounts for the thermal resistance provided by that layer. But you imagine you've all seen it after a fresh snowfall, and you look at someone's roof across the street, and you can see exactly where the framing is for the rafters. Or you can, on a deck over living space, you watch the way the snow melts, and you know exactly where your framing is. That's heat loss being transferred through those assemblies, or those components of the assembly that breaks up that insulation. That's what's called a thermal bridge. Thermal bridging is very, very common. It's something that's been trying to be addressed for years and years and years on complex buildings. In particular, large buildings that have poured-in-place concrete, and they have the decks that stick out the sides. Those decks just really act like radiant fins. All the flooring just sucks that heat straight out the side. So it's one of the things they've been working on for a long time. What we're looking at now in Part 9 is the effective value of that insulation over that whole assembly. That includes that nominal insulation, that big stuff in the walls or whatever you're going to shove there. It includes the gypsum drywall on the inside. It includes your rain screen cavity, your cladding, and what different types of cladding affect the actual insulation value. It even includes something called an air film on the inside and the outside. And that's not something you can buy. Don't go buy it off the back of a truck. All that is it's saying that when air gets really, really close to a surface, it actually stagnates. It stays there. And the science shows that that air gives us a tiny little bit of insulation factor. And so there's an air film on the inside and the air film on the outside. And it doesn't matter whether it's a windy site or whether it's protected or overhang or whatever. The code gives the credit for that air film on both sides. So we're looking at this overall effective insulation factor, including all of these pieces. What that also takes into account is the fact that you have thermal bridges through that element. So that stud that we have on the right side that's gone straight into the strapping for the rain screen cavity, that's going to allow some heat loss. And that's okay. Heat loss is okay as long as it's accounted for and we understand where it's going. We try and minimize it as much as possible. So that's the major difference of what the RSI or the R value is being calculated in 936. This is a global change, a massive change from what's been done before in terms of our usual designers and what they're speccing on drawings or what builders are trying to deal with on site. So for the studs, and for anywhere we don't have what's called a continuous plane, we do something called the parallel path flow method. And it emphasizes the fact that insulation will stop that heat transfer, and elements that break that up, like the studs, will allow more heat loss through it. And it's basically an area ratio. You guys don't have to know how to do this. The code will teach it to you if you need it, but just so you can understand the basic concept behind it, you look at the area of the insulation, and you look at the area of the elements that are acting as thermal bridges. You do a bit of a calculation, and you can figure out what the overall effective R value of that assembly is. So the calculations include repetitive structural members, studs, joists, lintels, sills, and plates. And it does not have to include those minor penetrations like pipes, ducts, or packaged air conditioners and things like shelf angles. So there are some things that the code allows you to ignore just from an ease of doing the calculation element, but this is the basic way to do that analysis. As an example of what we're dealing with, your standard 2x6 wall, 16 inches on center with an R20 batt, something we see very, very often in the Lower Mainland. That was considered a nominal R20 because it had an R20 batt in the wall, but its effective R value, by the time you think about all that thermal regime, you look at everything from the exterior air film and all the cladding and the rain screen cavity and all those elements right up into the gypsum wallboard on the inside, you actually only get an effective R value of 17.2. So even after you include all those elements, you're actually still less than what just an R20 batt is. You can see the rest of the elements there. The last one, the lowest one, is the 2x6 steel studs. Steel is a greater conductor of heat than wood. That R20 nominal goes right down to R11.35. The only one that goes up is the third one, where you have the special piece is that R10 extruded polystyrene that's on the outside of the wall assembly. So now you have a new continuous insulation element. It's breaking the thermal bridges. That R22 nominal R value actually goes up to R22.4. So typically you're going to see things go down unless the building has a sweater on, unless people have wrapped something else around the house. Other interesting thing, and it may not affect the Lower Mainland so much, but it's going to, as soon as you start going outside the Lower Mainland or building on top of Burnaby Mountain, or you're looking at building out sort of Chilliwack Hope Way, when you start to get a little bit outside of the Lower Mainland, there's different climate zones now, more than just 3. There's now 5. Zone 4 is our lower mainland area. Zone 5 is the top of Burnaby Mountain, and you can start to see around Hope area, and it goes up from there, 6, 7A, and 7B. If you don't have an HRV, that allows you, that requires you to have a little bit more insulation in your building envelope. If you do have an HRV, you do get a little bit of relaxation. So this is good news for the HVAC industry. If people don't want to have such a thick wall, then you guys can promote the fact that as soon as you put an HRV on the building, some of your insulation factors are actually reduced. To help the designers out, just so you guys know, the Canadian Wood Council has put some effort into developing a calculator to do a lot of that math to figure out the effective R value for various assemblies. Just a couple of different assemblies that we've got there for you guys to have a look at. Although it's probably too small for you to read anyway, but we can talk about it later. One of the resources that you guys might want to be aware of is the HBO, in conjunction with the Building Safety Standards Branch, put out an illustrated guide to the new 936. This is one of the graphics that comes out of that. It's a nice little cheat sheet of all the different elements that need to be accounted for, including skylights, windows and doors, floors over unheated spaces. If there's a garage attached, if there isn't a garage attached, that actually makes a bit of a difference as well. And one of the other things that we wanted to talk about, and as I said, when you have that rigid insulation on the outside, is the continuity of insulation. The building code now says you must have, must pay attention to the continuity insulation. That doesn't mean it is continuous. It means that you need to have insulation throughout the building envelope, so you can't just leave a hole. It seems pretty self-explanatory that you want to have insulation throughout your building envelope, but it's something that had to be said. The continuity of insulation doesn't mean that it is continuous. The one on the right side is continuous. It has an exterior rigid insulation, like a sweater on the house, but it doesn't have to be that way. Already talked through all that. Some of the places where getting that continuity of insulation is really difficult. Foundation walls behind electrical panels that are shoved in exterior walls. You actually have to now think about the fact that you are reducing that effective R value because you've compressed the bat or whatever you've done, removed the bat even, behind that electrical panel. You still have to get that overall same level of effective insulation behind those elements. So things like ducts, things like electrical panels, chases, plumbing stacks, anything that goes in an exterior wall that has to have a certain effective insulation factor, that can't be reduced. So it's a big red flag. Don't put anything in an outside wall if you don't have to. Put everything in an inside wall. One of the other elements that the building code now pays a lot of attention to is airtightness. 925, which is another part of Part 9, does currently require an airtight building envelope. 936 addresses the construction of the air barrier details from a heat loss point of view. So 925 in terms of materials and how that building envelope is given, an air barrier still applies. 936 layers on top of that. No testing is required in terms of airtightness. So we still haven't gone, we're still not at the point where they're doing a blower door test and looking at the air changes in that house, but it is some more attention. Air barriers have to be continuous across joints, between assemblies, and around penetrations. Again, something that might be considered quite self-explanatory, but it's given a lot more attention in the code. The building code is now really specific about how you achieve that airtightness. Caulking, sealants, spray foam, gaskets, and tapes, they all have to be installed a certain way. They have to be non-hardening. It's actually very difficult from a building inspector point of view to keep track of this, because if they didn't caulk underneath that sill plate before they put that wall up, well, you have to kind of hope that they did it. You can see on the right, you've got around an electrical box through the plumbing chase into the attic at the top right. The bottom left, that is actually a secondary wall that's built on the inside of a house that's going after a passive house. So that's using plywood or OSB as the air barrier and an airtight tape on top of that. Some of the things have changed in terms of installing your standard. If you're using poly as your air barrier, it has to be structurally supported. You can't just have it running, as you can see in the top right, or the top, you can't just have it running between the joists. It actually has to, or the studs, it actually has to run along something that you can press that tape onto. The thought being that if someone's trying to actually achieve an airtight barrier, on that, the bat will collapse behind and you won't be able to get that proper seal. Same with the bottom one that's speaking about the horizontal tape that's going across the top. Airtightness leaks out everywhere, and it's one of those things that's really hard to test until you get to the end of the building. But the illustrated guide that I referred to earlier has a whole big list of things to be aware of in terms of airtightness. A lot of it does affect what you guys do in terms of keeping that airtightness level in high attention. And unfortunately, it's something that you guys might come through and do your work, and then it gets mucked up by someone else or augmented in the ways that you're not pleased about. So it really does take attention from every trade that goes onto the job, because we do try and focus that whole building as a system approach on this. But the illustrated guide has a lot of help to that. And this is directly out of the illustrated guide, looking at a number of different places that you will have to focus on. For example, the foundation to sill plates on the right. As I said, if they haven't caulked that sill plate, it's going to be incredibly difficult to get that later on. One of the things that we're seeing for airtightness, or what we expect to see as we go through this, is moving that air barrier from the inside of the house to the outside of the house, and taking a house wrap approach, and just making it much easier to deal with, so that you don't have your electrical boxes penetrating that, and then if you have anything in the exterior wall in terms of ducting or plumbing stacks, it's not having to worry about that. So having an exterior air barrier might be something that we'll see a little bit more often. Plumbing stacks, again, you have to seal around all of the penetrations. Skylights as well. Skylights are horrible for this. Pot lights, from an electrical point of view, pot lights are extremely difficult to handle from an airtightness aspect, and attic hatches as well. And there's the electrical piece I was talking about.